Hello friends, this is Shravan Kumar Manthri. Welcome to our channel CSE GURUS. As part of the technical C, so in this video we'll see the concept of sorting. The techniques as well as the complexities. Of course the complexities are very most important, right? So we'll see all these things in this series of video lectures. Before that, I'm very much happy for the response of the videos like top 100 CMCQs and next 50 CMCQs. So thank you for your great response for these two videos. Thank you. And thank you for your response in my channel CSE GURUS. So thank you everyone and keep learning. Moving on to the concept of sorting. Okay. So we'll see what is this sorting first of all and the sorting techniques with their complexities. So what is sorting? Of course it is a process through which the data are arranged according to their values in it might be increasing or decreasing order. If you see like this, let us suppose these are the elements you have. These are the elements in a list. So 34, 70, 91, 86, 15, 43. So how this list can be in an arranging? It might be increasing. Of course you can make it in decreasing order also. Right? So here we can see this is increasing order. How to make it? What are the methods we have? What are the techniques we have to make it in a proper manner, that is in an arrangement? Okay, so that's what it might be, increasing or decreasing. How to do this one? So that is what we have to see and we have to analyze. So in this series of video lectures I want to cover these sort of the sorting techniques. You can see selection, bubble, insertion, quick merge, heap sort, radix sort, bucket sort, counting sort, as well as of course the sorting the strings in a dictionary order. That means a set of names are given, so how to sort according to the dictionary order. Okay, so like if a name starts with A, if both the names are starts with A, you have to check with AA. Is that right? So how to do all these things, that also we'll see. So these are the sorting techniques. Not only this, if possible I'll cover more sort of the sorting techniques like topological sort is also there and much more, and sorting the elements in a matrix. How to do? Of course all those things I want to do, I want to cover. And of course the very much important, I told you, like complexities. So what are the complexities? So we'll see, we will compare one sorting technique with the other one and which is the best one and what sort of the techniques. Some sort of the techniques where the swapping is a major part and some more where which are non-swapping sorting techniques. So what are those? How to do? So all those things we will see in the series of video lectures. Yeah, moving on to the first one, selection sort. So what is the selection sort? Of course any sorting technique, if you observe, you can find the meaning of the sorting in the name itself mostly. Okay, so in the selection sorting here also, so the selecting an element, selecting a value which is either minimum or maximum. If it is increasing order it might be minimum, if it is decreasing order it might be maximum. So you have to select and keep it in a particular place, that is might be in the beginning. Okay, so let me take an animated way where the list of elements to be sorted using selection sort. Of course I mentioned here the selection sort uses sorted sublist and unsorted sublist. Your list, your array will be divided into two parts. One is sorted sublist and another one is unsorted sublist. Of course in this one we'll see selection sort with example. Of course what is a program? Of course C program without separate function, with separate function. Okay, we have to define a function, right? So how to get a program with separate function, or we can write in main function directly. Okay, that is not a big deal. And execution, of course I execute both. Okay, I'll show you. Sorting only first half of elements, you want to sort only half of the elements. How to do? Sorting only second half of elements. What sort of the minor changes I need to do? Okay, so that is all. And some questions will be asked like arranging the only first half of elements in increasing and second half of elements in decreasing order. How to do? And finally analysis, that is a complexity of a selection sort. Okay, so these are the things we'll see now. So the example you can see here, so I have taken the list. Okay, initially of course here I have given the list sorted sublist, that means the line where I have provided this black line, this separator, which the left part will be always sorted and right part will be unsorted. Initially all are unsorted, right? Initially the elements are unsorted. Of course, might be you can give the sorted list also, that is not a wrong one, of course. But whenever I say this line, the left elements will be sorted, right elements will be unsorted. Initially the process not yet started, that's why left of the line is empty, that's why sorted list is empty, unsorted list is full, you can see. Now the first step, what is that step? I told you, like, the first thing you have to find, let us suppose it is increasing order, you have to find the minimum among all the elements. Initially all the elements, of course I can say it is like minimum of unsorted sublist. You have to find minimum of unsorted sublist. So what is the minimum of unsorted sublist? So you can see here among these elements 8 is the minimum, right? You have to get that element, smallest of all the elements logic you can use, and you will get that 8 is the minimum. Now what you need to do, whenever you get a minimum element, what you need to do, you have to swap with the first element, initial element, okay, in the unsorted sublist. Remember this point, you have to sort with minimum element, you have to swap with minimum element and the first element in the unsorted sublist. You can see first element is 25 and this minimum element is 8. Now I'll swap, you can see, yeah. Now the separator, you can say left part is sorted, right part is unsorted sublist. Now what is the minimum value? 25, right? So 25 to be swapping with, I told you, the first value in the unsorted. You cannot swap with 8, right? It is a sorted one. So 85 and 25, is that right? So minimum value is 25 among unsorted sublist and my first value is 85. So swap. Now it will become like this. Now the separator will be here. Why? Because 8 and 25, two elements are sorted, the remaining elements are unsorted. Now again from the remaining elements you can see, of course, the 32 is minimum, 48 which is the first element in the unsorted, swap it. Now the separator will be here. Now 85, 48, 56, which is the smallest? 48, yes, fine. So swap with the first element 85, okay, yeah. Now the separator will be here. You can see 4 sorted elements, only 2 unsorted. Again you continue, of course 85 and 56 sorted like this. Now the things to be observed here is, the first thing, you have to find a minimum element. Of course if you want to make it for decreasing order, you have to find maximum. Second thing, swapping. Am I correct? The third part, which is, you can observe one more thing, like if there are n elements, let us suppose how many elements are there? 6 elements are there, then you have only 5 pass. That means if there are n elements, you have require n minus 1 passes. That means for the last element, of course not required to pass, right? If there are 20 elements, 19, at most 19 passes are enough. Is that right? So these things you need to consider, and like this it will be. So in the selection chart, you have to select the value which is the minimum, then you have to swap with the unsorted sublist. Like this it will be, finally all elements will be sorted. Of course if you want to make in decreasing order, you have to select the maximum element, okay. So keep it in the swap with the first element in the unsorted. Now you will get the decreasing order. That's it, right? So this is what the procedure you can find for selection sort. So this is an example. Of course if you want to try, you can try for this. You can take this element and you can practice. You can take these elements. What is the minimum element? 15. So you have to swap 15 with the 34, right? So here 15, here 34 will come, and what is the next smallest among these elements? 34. So 34 will be swapping with 70, like this. So this is what the procedure you need to follow, and next smallest among unsorted sublist will be 43, right? So like this. So this is what you can complete this procedure so that you will get the elements. So now this sort of the selection sort procedure, how you can implement. So I told you the first thing you have to find the minimum, second thing swapping with the unsorted, so the first element of the unsorted. So how to get that, I'll directly show the code and afterwards I'll execute also. Okay, yeah, this is the code. You can see the selection sort process. So initial I have taken an array, of course the size you can take any. Okay, I've taken very less size. Okay, yeah, minimum a variable to get the minimum index. Okay, yeah, temporary variable to swap. Okay, I've taken, anyway we can see enter the size of an array. So I'll enter the size, how many elements you want to take and what are those elements I have given. Because this part is just to declare, I mean to get the, to take the inputs. Okay, this part is a declaration, this is taking the inputs till the line 10, right? Now the logic resets from line number 11 up till 22. Okay, yeah, you can see here for I equals 0, I told you yn minus 1. So that's what this process, if there are n passes, n variable, if there are n elements, you require n minus 1 passes only. So that's why you can see here 0 to up to n minus 2, right? Yeah, that is what, that means less than means. So that is what here we require. That's why it is n minus 1 times I need to do. What I need to do, I have to find the minimum in the unsorted sublist. You can see here minimum equals to initially starting with 0. So initial value is 0, minimum. Now j starts from what? I 0 plus 1, 1. So you are finding, this is a logic to find the minimum, the index of the minimum value. Of course, if you see here, if you apply here, if you trace minimum equals 0, j equals to 1. If a of j, what is a of 1? This is index starts from 0, right? So like this indices. So what is a of 1? 85. Is that 85 is less than, minimum is 0. 85 is less than 25? No, right? Next j value 1, next j value 2. 48 is less than 25? No. Next j value 3. 8 is less than 25? Now it is true. Now minimum is changing. Minimum is changing from 0 to 3, right? Yeah. Now j value will be incremented to 4. Now 32 is less than, shall I check with 8 or 25? 8 only. Why? Because minimum, the index is changed. So 32 is less than 8? No. Is that right? So now it's not changing. Next one, j value is 5 finally. And 56 is less than 8? No. So then j loop completes and now completed. So what is the minimum index? 3. That means what is a of 3? 8 is the smallest element. Now I need to swap, right? 8 with 25. You can see I have taken temporary. Temp equals to a of I. A of I means what is I value? 0. That is a of 0, 25. Next a of I equals to, so what is a of 0? Equals to a of min, a of 3. It is 8. And a of min is nothing but a of 3, which is equals to temp, which is therein, that is 25. So a of 0, 8. A of 3, 25. So simple swapping, right? So this part has to be completed like this. Finally you may print. This process has to be completed. Now minimum equals to I, that means min starts from 1, right? So that means only this is a sorted, this is unsorted, and this part has to be completed up till, that is it started from 0, that's why n minus 2, right? So this is what the program of selection sort. Of course this logic I implemented with separate function, that also you can see here. So here selection set, of course I have, instead of writing the logic directly, I apply, I'm calling selection of a is an array, comma n. Of course simply a, if you call this, directly goes to the address of a of 0, right? So concept of the pointer, and here it goes, and again the logic is same. Instead of taking min, I have taken small here, the variable, and again the same thing will be printed, right? So now we'll see the execution part. Okay, we'll see the outputs first. Okay, how it can be executed. I just copied this so that is a main function. I have taken the element selection function, and here it is a selection function. This is a logic for finding the smallest. Here this part is finding the smallest, and then whatever the answer you are getting, so from that swapping. Okay, yeah. Then we'll see the execution part of this one. Yeah, enter the number of elements. Here we can see, let us suppose I'll take the elements like 6 elements. The elements are something like 25, something like 56, I'll take something like 8, 85 I'll take, 72 I'll take, so one more element 65 I'll take. So the output we'll see. Yeah, you can see the elements which are 25, 56, 8, 85, 72 and 65. You can see the output 8, 25, 56, 65, 72, 85. So which is a sorted one. Now you may think that, okay, if you want to see the entire process, how in each pass it has to select the smallest, right? So that we'll see now. Okay, what are the changes you have to do? So what I'll do here is this for loop, instead of writing outside of this for loop, anyway this is outside the I for loop, right? So I'll keep this one inside. That means every time what happened, like how the elements are printing. Okay, instead of taking I variable, why? Because I value is changing every time, right? So I'll make it as k. So this is simply to show effective output, that's it. So k, of course the k variable has to be declared. Now the thing is, every time it has to print in new line, right? So I'll keep here as printf 1/n I'll provide, so that will be printed in new line. Now we'll see the output. Yeah, elements I'm entering something like 25, 86, 8. So enter the number of elements. I'll take something like 7. So the element is like 25, 86, 8, 35, something like 56 and 72. Okay, one more element has to be given, right? 7 elements, something like 43. We will see this output. Yeah, in the first pass you can see 8 is the smallest, 8 is kept. The remaining elements you can see 86, 25 are unsorted. In the next pass, in the second line, 8, 25, 86, 35, 56, 72, what is the smallest? 25, of course kept here. Now from the next one you can see what is the smallest? 35, you can see here. Next 4 elements, what is the smallest? 43 here. Next 3 elements, 56, 72, 86, 56 is smallest, and 72, 86, 72 is smallest. Now one more thing also you can observe here, 7 elements, how many passes are completed? 1, 2, 3, 4, 5, 6. That's what, n elements are there, n minus 1 passes are required. So like this we can get the output. See, the questions which we have completed here is selection sort example is over with the without separate function. With separate function, of course, both execution, of course I have shown you. Only now we have to see what is only first half of elements to be sorted, what is only second half of elements to be sorted. Okay, we'll see this one also. Very simple thing which we have to do. Okay, so we'll see that one. Let us suppose these elements are given. I want to sort only half of the elements, 25, 85, 48. What will be the output? 25, 48, 85. This part should be as it is, right? If I want to only sort second half of elements, 8, 32, 56, what I need to do? Where the logic has to be changed in the R program. Okay, where I need to change, we'll see now. Yeah, in my program you can see here I have taken the entire elements, but I want to sort only half of the elements. That means we have to go for, if there are n elements, we have to sort only n by 2, right? So where I need to change, I need to go for only first half of element. That's why first I want to make only n by 2, that is I less than n by 2, right? N minus 1 by 2 is there, so only half of elements. Okay, we'll make it some changes so that we'll get the output n by 2 minus 1. Is there any need to give braces like this? I think not required. Why? Because division is the first priority. Why I have given minus 1 means, let us suppose if there are 8 elements, the index starts from 0, right? 0 to 7, right? So we need to sort up to index 3. Why? Because 0, 1, 2, 3, right? So that means we need, in order to get 3, we have to write 7 by 2, which is 3 minus 1, up to 2 only it is taking, right? So I think n by 2 is fine. Let us suppose if I take n by 2, 8 by 2, sorry, 8 by 2, which is 4. Okay, so that's why minus 1, right? If there are 7 elements, 7 by 2, which is, of course, yeah, half. If it is odd, only you have to take, you need to check it out which part you require. According to that you can change this one, right? Yeah, here also j less than y to that n by 2 is fine, right? So only half of the elements. I think that's it. We need to change in this function, that is selection function. Nothing more to change, right? So anyway, we'll see the execution part of this one. Yeah, enter the elements. I'll take the elements, 6 elements, something like 45, 76, 24, then 7 I'll take, and 85 I'll take, 32 I'll take. So the output should be only first half of elements, that is 45, 76, 24, which becomes like 24, 45, 76, and 7, 85, 32 will be as it is. We'll see the output. Yeah, you can see the output. Anyway, I've written the for loop inside, right? That's why. So 25, 40, 24, 45, 76, which are sorted, and second half 7, 85, 32, which are unsorted. So only one time, the last part you want to print, you can take it. You can keep this one outside. That means simply this closing brace you have to keep here. That's it. So we have to keep that. So you have to keep that brace outside. So this is what one change. If I keep this brace here inside, that means there is a loop inside and every pass will be printed. If you keep this for loop outside, only final answer will be printed. Now we'll see this output. I'm taking 6 elements, 43, 25, 78, 9, 65, 27. Okay. Yeah, now you can see the answer. Only first half of elements 25, 43, 78 are sorted. The remaining half elements 9, 65, 27 are unsorted. That is, you don't want to change. Okay, so like this we can go for only first half of elements to be sorted. What if only second half of elements to be sorted? Let us suppose if I give the same elements 43, 25, 78 to be same, unchanged, and only 9, 65, 27 which is to be sorted, 9, 27, 65 to become. So what we need to do in our program? So what are the changes I need to do? Anyway, I'll keep it my original complete sort program. In that only we have to see, so that you can understand it easily. Yeah, now in this I want to sort only second half of elements. I think we have to do only one change. What is that? Here you can see I starts with 0, right? So instead of I starts 0, I'll start I with n by 2. That's it. No need to change I less than, no need to change j less than. That's it. I think if you want, you can check it out. Anyway, some minute changes according to your output, like if it is odd size, you can make it. Okay, So my intention is to tell like, so the remaining part of the program is unchanged, right? So if I take the elements 25, 45, 32, then taking 9, then 65, 54. So you can see the output now 25, 45, 32 as it is, and 9, 65, 54. If I sort, it will become 9, 54, 65. So like this we have to do. So that is for second. Okay, yeah. Now the thing is, we have completed like first half of element only to be sorted, second half of elements only to be sorted. Now the next question is, you have to sort first half of the elements in increasing, second half of elements in decreasing, right? So of course you may have some methods, but what is the best, what is the easiest one? Like when you code, how you can get the answer when you are already with this answer? What you need to do here, that means I want to sort only first half of elements. So first that is increasing order, second half in decreasing order. Okay, and one more thing you can see here, all the elements, let us suppose if I keep the original one, this one, this is the program where it will print all the elements in increasing order, right? So what if I want to make it in decreasing order? That means what is the only one change you have to do in this one? That is, instead of a of small greater, you have to keep it as less than. Of course your total elements will be in decreasing order. Of course you can see this one also, the output. Let us suppose if I give 6 elements, 25, 8, 89, 43, 5, 54. So 6 elements, you can see the answer 89, 54, 43, 25, 8 and 5, which are decreasing order. So now the question is asking to make first half of an increasing, second half in decreasing. So the very simple answer what I'll do here is, this logic is for increasing order of the elements. Now what I'll do here is, I'll just copy it. First I'll copy this part, so in the next line immediately I'll paste it. Okay, now the first part I will take, and this I'll use for first half of elements. This part which is a copied one I'll use for second half of elements. Now you can see here how to get the increasing order of first half of elements. Anyway, we have done it. We made it n by 2 minus 1, and this one also n by 2. So this is for increasing order of the first half of it. And what about this one? Here I have to use for second half of elements. Anyway, first thing it should be decreasing, right? So first thing greater than should become less than, right? And for second half of elements, I told you like only to change, I starts from n by 2. That's it. Okay, so like this, and the remaining things to be unchanged. So this for loop is from 17th line to 29. It is for increasing order of first elements, and the 30th line to 42, this is for decreasing order of second half of elements. We'll see the output. Enter the number of elements. 8 I'll take. Okay, 34 I'll give 76, 8, and then 89 I'll take. Second half of elements I'll take 70, 74, 43, 7 I'll take, and then 65. So totally 8 elements. We'll see the output. See, first half of elements 34, 76, 8, 89, these are in increasing order. Second half of elements 74, 43, 7, 65, these are in decreasing order. So like this we have to make increasing and decreasing orders. So only first half of elements in increasing, second half of elements in decreasing order. So we have to change the code. So here my intention is to explain, like if you know the answer of this one, how to sort the entire elements, you can make some changes so that you can get how to take sort only first half, only second half, arranging in first half in increasing and second half in decreasing. This might be very easy. Okay, so this is what. And the final one, complexity. So what is a complexity here? Coming to the complexity part, even if you see in selection sort, where even if you give any sort, any order of elements, any type of order of the elements, even if you give increasing and decreasing, this process has to be completed, right? Like every time I starts from 0 till goes to n minus 1, j also, j starts from I plus 1. Okay, yeah, so that's why the process which takes the nested for loop must be taken, must be completed. So that's why it will be taken as n square. So the complexity will be order of n square, even in best case, worst case and average case also. So there is no special constraint like how to make in like which should be less than the n square. So this is what about selection sort program. In the next we'll see the concept of bubble sort, of course the special property of bubble sort, that is also it. We'll see, that is how can you get the complexity of big O of n in the bubble sort, what is that special case also we'll see. Thank you.